So as you can see, we rendered our Google inside our tab, but when we minimize our tab preview shows white color, because as you can see in our empty frame RL there is one tab preview, and on top of that frame we have empty frame LRL, which contains this title, favicon and close tab IB. So we want to render our tab preview inside this image button tab preview IB. So I know that you are wondering why this tab preview IB image button exists over here. It exists because consider when we render google.com inside our web view and we made our tab minimize, and we so for example when we rendered our for example we render google.com inside web view and we just made our tab minimize, then we want to make this content inaccessible when tab is in minimized state. Hence we need a new frame on top of this web view. Hence we created this empty frame RL, which exists at the top of this web page, that is web view. So on top of this frame we have this frame, and since we are accessing this top frame, our web view remains untouched. Hence this image button is present, but as of now it is showing a white color because we used its background as color surface. Now we can do one thing, we can set its background to @Android color transparent, and it can show the content of our web page because its background is transparent. But there is one problem. If we set like so, our tab manager performance is badly reduced because it rendered high quality frames as preview of our tabs. Hence scrolling performance will get badly impacted. Hence we do not want to render this web page as it is, and we want to make preview from our web page. So we will not use @Android color transparent as background for image button. Instead we will capture tab preview from our tab and we will compress it, and then we will show that preview in our image button, so that our scrolling performance of tab manager will not get impacted and we get smooth scrolling inside our tab manager. So for that we need to create some helper methods and classes inside our normal tab survey adapter view holder. The first class we are going to make is, so after the constructor, as you can see, after this public view holder constructor we will create one class, private class draw bitmap, and it will extend thread. Then we will create empty constructor of this draw bitmap class. It will not take anything, and we will override its run method since it is a thread. So after the super call we will create a try block. In the try block we will create a raw bitmap, and we will use bitmap.createBitmap, and we need to pass the width and height. So we will pass recycler view container width, and we will pass, so our emulator is impacting Android Studio performance. So for now I am going to close this emulator, and thereafter we will pass recycler view container height. Now it takes third parameter, that is compression format. So we will pass bitmap dot config dot rgb underscore 565. So as you can see, there are multiple formats available for bitmap configuration: alpha 8, ARGB 8888, RGB 1010 102, RGB F16, ARGB 4444. So that will pick the alpha values and RGB values, but our case is well handled by this RGB 565 format. So we will use RGB 565 for creating bitmap. Then we will create canvas. C is equal to new canvas, and we will pass our raw bitmap. Then we have the outer L. Outer L is nothing but our constant layout, which is parent of all layouts. That is, it is parent of bottom toolbar. Then this top bar and divider and home page container and also web view container. So when we draw bitmap using this outer L, it will capture perfect preview for our tab. So we will use outer L dot draw, and we will pass canvas, that is C. So thereafter we will create bitmap result bitmap is equal to bitmap dot create bitmap, and we will pass new width and new height, and this time also we will use bitmap dot config dot 565, that is RGB underscore 565. So as you can see, we declared our new width and new height in this set specs function. So it will reduce our recycler view container width and height to half size, and we also reduced scale X and Y using this. So it will compress our bitmap and make it smaller. That will improve the rendering performance. So thereafter we will use matrix, scale matrix is equal to, we will create a new matrix, and then we will set scale matrix dot set scale, and we will pass scale X, scale Y, and 0f as px and 0f as py. So scale X and scale Y are set in our set specs function using this division. So basically we are trying to compress our bitmap to improve rendering performance. So after that we will create canvas. Canvas is equal to new canvas, and we will pass result bitmap. Then we will set canvas dot set matrix, and we will pass matrix, that is our scale matrix. Thereafter we will draw bitmap using canvas dot draw bitmap, and we will pass raw bitmap, then 0 as left, 0 as top, and we will pass paint. Thereafter we will recycle our raw bitmap using raw bitmap dot recycle. So it will recycle our old bitmap, that is raw bitmap. Then since this is background thread, we need to call some code on our user interface thread, because some code that is setting text, setting bitmap is not accessible from the background thread, it needs to be called on UI thread. So we will call activity, that is our main activity, dot run on UI thread, and we will pass the new runnable that will run on the user interface thread. So in this we will create a try catch block, and in the try block we will set tab preview ib dot set image bitmap to the result bitmap, and we will set future is equal to null. Then we will catch exception E. If there is any exception, then by default we will create one more try catch block, and this time we will ignore exception if there is any. And in this try block we will set tab preview dot set background color, and we already captured our color surface in color surface variable from the currently applied theme, so we'll use it over here, and we will set future is equal to null. So we have one more try block. So for that we need to create catch exception E. If there is any exception, then we will run the code on the UI thread. So we'll use main activity dot run on UI thread, and we will pass new runnable, and in this we will again set background color of tab preview to color surface. We will make future is equal to null inside try catch block. So just copy this block over here and use lambda, so replace with lambda. So I know that you are wondering what is this future and what is this paint. So as you can see, we declared this paint in our ready project at the top of normal types RV adapter. So we will do the same thing. We will declare this paint at the top because it is used again and again repeatedly. And we will import android.graphics.paint. Now since it is final, we need to initialize it in our constructor. So we'll initialize it over here using paint is equal to new paint, and we will pass paint dot filter bitmap flag. So we are going to use this paint. As you can see, we use this over here, canvas dot draw bitmap paint over here. Now I know that you are wondering what is this future. So future represents a future which is being passed. So what is executor service? So there are two questions, what is executor service and what is future. So as you can see, we declare those two in our viewholder class. So in the viewholder class we need to declare those two, and we need to import executor service and the future. So as you can see, our draw bitmap class is a thread. Executor service accepts thread and it returns future, and it executes those threads one by one. Previously there is one class which is existed. It is called async task, but since in the later versions it is deprecated, we are going to use this executor service over here. So we will submit our draw bitmap thread to this executor service, which will return future to us, and we can handle this future. We can cancel this future using future.cancel. That will cancel the ongoing execution of executor service, that will halt the draw bitmap functionality if we cancel this future. So we are going to use this future for cancelling that draw bitmap task, that is our thread. So as you can see, executor service implements executor, and an executor that provides methods to manage termination and methods that can produce a future for tracking progress of one or more asynchronous tasks. An executor service can be shut down, which will cause it to reject new tasks. So basically, it will accept the thread, it will return the future, and we can use this future to cancel it anytime if we want to halt the execution of executor service. So these are the usage examples of executor service. For example, here as you can see, this network service implements a runnable, again it is a thread, and this can be executed using executor service. So those are all its methods: shut down now, submit, and we can submit task. So we use this executor service for our purpose of drawing bitmap. So as you can see, we declared our service as executor dot new single thread executor because we want to supply only a single thread to be executed to our executor service. Hence we declared it as executors dot new single thread executor. But where do we submit thread to our executor service? So for that, as you can see, we are minimizing our tab in tabs count child tv hprl on click listener using minimal deselect item. So we need to tweak this minimal deselect item little bit so that we can execute draw bitmap thread on our inside our executor service that will capture tab preview. So here we will tweak our code. We'll set is layout invisible to false. We'll set view holder that we are going to create at the top to null. Then we will hide keyboard, that is our soft keyboard, which is visible to user using input method manager imm is equal to context dot get system service, and we'll get activity dot input method service. We need to cast this to input method manager, and we'll check if imm is not equal to null. If it is not equal to null, then that means that the soft keyboard is visible to user, hence we want to hide this from screen. So we will use imm dot hide soft input from window, and we will pass item view dot get window token and the 0 flag, and we will ignore exception. So it will hide a soft keyboard if it is visible to user. Then we will call make title visible, and thereafter we will call minimal deselect item, and when it returns a runnable, that is a setter callback, we will capture our image preview inside try catch block. We will catch an exception E, and in the try block, first of all we will check if future is equal to null. If it is null, then only we will create a new future, that is we will store a new future using service dot submit, and we will submit a new draw bitmap thread to our executor service. So if the future is not equal to null, then that means that the future is already stored previously and it is currently running inside our executor service. So we do not need to do that execution one more time. Hence we check future is equal to null. If it is null, then only we will execute that future inside our executor service. So if there is any exception, then again we will set tab preview ib dot set background color to color surface, and we already did is layout invisible is equal to false at the top, hence we can remove this. And after this call we will make our empty frame RL visible. So our draw bitmap will do rendering. So our draw bitmap will catch and create bitmap for our tab, and we are going to use this as tab preview for our image button tab preview IB. That work it will do. So what is this view holder? Now this view holder will represent a currently expanded tab. Our tab is nothing but the view holder, hence we are going to declare this view holder at the top of our view holder class. So this is our view holder class constructor. So at the top we will declare private normal tabs RV adapter dot view holder. As you can see, this is ready version, and we declared normal tabs RV adapter dot view holder at the top of normal tabs RV adapter class, not at view holder class. So that needs to be at the top of normal tabs RV adapter class, so that it will represent the currently expanded tab. And we are going to use this view holder to store the currently expanded tab. So when we minimize tab, we set view holder to null. In the later videos, when we maximize tab, in this onClick method, we are going to set our view holder to viewholder.this, that is the current instance of viewholder class which is being expanded. So this viewholder will represent that expanded tab. Now we will create one more helper method above our viewholder class. Get view holder. It will be package level method, and it will return normal tab survey adapter dot view holder. So we are going to use this function in later videos. Now we successfully submitted our draw bitmap thread to executor service over here, but there are some cases in which we need to stop this service. For example, we need to call future.cancel in the close tab IB. So we need to tweak this code. So before this remove tab, we are going to call stop service. So it will stop our executor service. So we need to create this stop service function in our viewholder class. So we will create private void stop service, and in this function we will create a try catch block. We will ignore any exception if it occurs, and here we will check if service dot is shut down. If it is not shut down, then we will shut down that service using service dot shut down now. So it will shut down executor service of our currently represented tab, which is represented by the viewholder class. Now we will create one more method, private void stop fetcher. So in this we will stop fetching our bitmap preview. In the try catch block, we will ignore exception if it occurs. So we will check if future is not equal to null. If the future is not equal to null, then that means that there is some task currently ongoing, that is draw bitmap is currently being executed by executor service. So we need to cancel this future, this submitted futures, which is currently represented by the future variable. So in the try block, first of all we will check if future dot is cancelled. If it is not cancelled, then we will cancel that future using future dot cancel, and we will pass true. And in the final block we will make our future to null, so that this not get executed again and again. And we will call this top feature when we expand our tab, that is when we maximize our tab. So we maximize our tab over here, tab preview ib dot set on touch listener minimal select. We are maximizing our tab over here. So we will tweak this code little bit. We will check if it is not swiping, then we will first of all stop any draw bitmap thread which is being executed currently by our executor service, because we want to stop our draw bitmap function from creating our tab preview, because we want to stop a current generation of tab preview since we expanded our tab. Then we will make title bar invisible since we expanded our tab, and then we will select our tab using this minimal select function. And after this we will call one more method, select this tab, and we will pass true. So we need to create this select this tab function in our view holder class. So we will create private void select this tab function, which will accept boolean is relayout. So if relayout is true, then we are going to remeasure our current view later on in this course in our custom horizontal manager. So currently just pass this relayout value. Later on we will do its functionality. Later on we will create its functionality. So in this, first of all we will set empty frame rl dot set visibility to invisible, and we will set is layout invisible to true. Then we will set view holder is equal to view holder dot this view holder is declared at the top. As you can see, at the top of our normal types RV adapter class, we declared this view holder over here just before the constructor, which will represent the currently expanded tab. So when we select tab, we are going to instantiate this view holder. We are going to set view holder dot this to the view holder variable, so it will represent the currently expanded tab. Then since we expanded our tab, we will remove the previous image bitmap from tab preview ib using set image bitmap, and we will pass null. So it will remove the previously applied image bitmap from tab preview ib. Thereafter we will set tab preview ib dot set background color to color dot transparent temporarily, and thereafter we will call set ql. So set ql function will basically refresh our quick links. It will set the span count, and it will call set quick links method of our quick links RV homepage adapter that will refetch quick links from the database and will refresh the quick links for our currently expanded tab. So we are going to call this set ql from this select this tab. Thereafter we will call one more method, set tab count tv text, and we will pass get item count, and tabs count child TV HP to this set tab count TV text. So as you can see, we have tabs count child TV HPRL relative layout. Inside this we have this image view and one text view. Just look at this image. At our bottom up bar, this image view and the text view is present, which is currently representing the number of tabs which are currently present inside our tab manager. So we need to set this text to this text view. So we are going to reference tabs count child TV HP. We already referenced that inside our web view class, and we are going to create this set tab count TV text method inside our view holder, and we will pass the current tab count using get item count, and we will pass our text view instance, that is tabs count child TV HP, to this set tab count TV text method. And in that method we are going to set the text for our tab count text view. So we are going to create this set tab count TV text method. So we will create this method. Outside our view holder class, not inside our view holder class. So here we will create private void set tab count TV text, and we will use count as parameter, which will represent tab count, and we are going to accept text view tabs count child TV HP, and over here we will check if count is greater than 99, then we will set tabs count child TV HP dot set text, and we will pass our dot string dot max count, that is 99 plus. Else if this is not the case, then we are going to use tabs count child TV HP dot set text, and we will convert our past count to string using string dot value of, and we will pass our count. So this will set text to our tabs count child TV HP. Now we will create one more helper method, void set function, which will set tab count child TV text to get item count plus 1, and we will pass view holder dot tabs count child TV HP. So we will use this set method when we add a new tab inside tab manager. So we need to increment the current value. So we increased it using get item count plus 1. So if there are currently 0 tabs in tab manager, then we will use 0 plus 1, that is 1, as count, and it needs text view tabs count child TV HP. So our currently expanded tab will be represented by the view holder. So we will pass view holder dot tabs count child TV HP to set tab count TV text. So when we expand tab in onbind view holder later on, we are going to use this method. Currently we just declared it. So we are ready with our code. Just there is one more error, it is missing the semicolon. So now we are ready with our code. Now we will test functionality in our emulator. So as you can see, currently our preview is captured by our draw bitmap, but there is one bug. Our tab preview is small, so we are going to fix this bug in the next video.